Hello, and welcome to The Brief Insight, your go to podcast for breaking down the latest trends, research, and policies shaping our world. Whether you're passionate about sustainability, global economics, or emerging innovations, this is where we simplify complex ideas to keep you informed and inspired. If you enjoy what you hear, don't forget to like this episode, subscribe to our channel, and share it with anyone looking for insights that matter. We're here every Monday and Friday, so hit that notification bell to stay updated. Your support helps us grow and continue bringing you sharp, relevant content that sparks conversation. Thank you for tuning into The Brief Insight. Now let's dive into today's topic.
If you want to understand that sleek, clean, futuristic electric vehicle sitting in your driveway, you really have to stop looking at the software.
Right, yeah.
And you have to start looking at the dirt. Because right now, the green energy revolution is driving this frantic, honestly ruthless global scramble for just a handful of critical minerals.
Oh, absolutely.
And the sweeping international laws designed to protect that massive supply chain, well, they might actually be mathematically impossible to meet.
Yeah, we always assume the transition to green energy is this, frictionless Silicon Valley success story.
Right, totally.
But underneath the touchscreens and those aerodynamic designs, it is arguably the most complex geopolitical logistics puzzle we've seen since the Cold War.
It really is. So, welcome to the deep dive. Whether you're driving an EV right now or you're just watching the global grid shift toward renewables, you are personally downstream of this massive supply chain.
You're a part of it.
Exactly. And our goal today is to map out the hidden life cycle of that battery. We are pulling from a massive stack of research today. We've got a nature sustainability study on U.S. trade policy. We have on-the-ground human rights surveys from the University of Nottingham.
Which are just eye-opening, by the way.
Completely. Along with geopolitical infrastructure analyses from the Atlantic Council, some governance reports from UC Berkeley Law, and the technical blueprints for a new digital tracking system in Europe from Cognizant.
It's a lot of ground to cover. And it really requires a massive shift in perspective. To grasp what is happening, you have to look at these theoretical policy debates in Washington, then kind of zoom out to vast 800-mile rail corridors being carved through the African continent.
Which is wild to think about.
It is. And then finally, you have to drill all the way down into the microscopic digital data tracking the origin of a single grain of lithium.
Okay, let's unpack this and let's start with the policy. Because the United States government is trying to force the market to secure these minerals through the Inflation Reduction Act, right? The IRA. Right. And the headline rule here is massive. Basically, by 2027, if an automaker wants their EV to qualify for that sweet consumer tax credit, 80% of the critical minerals inside that car's battery must come from the U.S. or a country we have a free trade agreement with.
Yeah, the free trade countries or FTCs.
Right. But when you look at the nature sustainability modeling on this, the math simply does not work.
It really doesn't. So the research evaluated the most common battery chemistries on the market today. You have your LFP batteries.
Which stands for lithium iron phosphate. Right.
Exactly. And these are generally cheaper. They use really abundant materials like iron, but they are heavy.
Okay.
Then you have NMC batteries, which rely heavily on nickel, manganese, and cobalt. And those store a lot of energy in a much smaller space. But here's the kicker. For both of those dominant battery types, hitting that 80% domestic or free trade threshold for a fully electric vehicle by 2027, it's essentially impossible.
Wow. So they just can't do it.
Not with the current physical supply, no.
But wait, the only one the data suggests even comes close is the NCA battery, right? Where they swap out the manganese for aluminum.
Right, but even then, the study says that requires they call it a maximum availability scenario.
Which sounds like a polite way of describing an economic fantasy.
Oh, 100%. A maximum availability scenario assumes the United States somehow manages to buy up every single eligible mineral export from all of its free trade partners simultaneously.
Just hogging the entire market.
Exactly. It assumes no other nation, not our European allies, not Asian manufacturing hubs. It assumes literally no one else is competing for those exact same resources.
Which is obviously never going to happen.
Mm.
But the part of the policy that really seems fundamentally broken to me is how the U.S. government is measuring that 80% threshold.
Oh, the market value metric.
Yes, because they aren't measuring the physical weight of the rock. They are measuring it by market value. To me, targeting market value instead of mass is it's like trying to diet by tracking how much money you spend on food rather than the calories.
That is a perfect analogy.
Right, because it doesn't actually measure the thing you are trying to restrict.
And what's fascinating here is that this structural flaw creates these completely bizarre outcomes. Take cobalt, for example.
Okay.
Since 2019, the global price of a ton of cobalt has spiked by as much as $13,000 just due to market volatility.
Wait, $13,000 a ton? That's insane.
Yeah, so under the IRA rules, if a manufacturer uses the exact same physical amount of cobalt from a free trade partner, but the global price skyrockets, the total market value of their compliant minerals artificially inflates.
Oh, I see. So they suddenly hit that 80% target on paper without securing a single extra ounce of secure domestic minerals.
Exactly. An auto executive spreadsheet becomes legally compliant purely because of a price spike on the London Metal Exchange.
That is wild, but the modeling actually shows what would happen if regulators measured by mass instead of dollars, right?
Yeah, they ran that simulation. If the policy demanded 80% by weight, the entire bottleneck just shifts.
Because cobalt is expensive but light.
Right. You don't use much of it. Graphite, on the other hand, is relatively cheap, but extremely heavy. I mean, it makes up a massive portion of the battery's mass.
Gotcha.
But the crazy thing is, shifting the metric to mass still results in failure. There simply isn't enough eligible graphite or cobalt being mined in friendly nations to feed the projected demand.
Which introduces what the researchers call gamesmanship. Because if auto companies can't secure the minerals legitimately, they're going to find loopholes.
Oh, they always do.
And the way the IRA is written, the minerals only have to be extracted or processed in the U.S. or a free trade country.
Yeah, the word "or" is doing a tremendous amount of heavy lifting in that legislation.
Definitely.
The mechanics of this loophole are surprisingly straightforward. Imagine a mining operation in Argentina, right? A country that does not have a comprehensive free trade agreement with the U.S.
And probably might not adhere to the same stringent labor or environmental standards.
Exactly. So a company could extract lithium there, put it on a ship, and send it to a processing facility in a free trade country.
And because the chemical processing technically alters the tariff classification of the material, customs just treats it as originating from that friendly port.
Yeah. It essentially washes the lithium's origin. The material legally qualifies for the U.S. tax credit, but the actual physical supply chain is still completely dependent on a non-free trade nation.
So you haven't actually improved the environmental or ethical security of the extraction at all?
Not even a little bit. The research actually draws a direct parallel to the U.S. biofuels mandate from back in 2007.
Oh, right.
Where the government set these massive production targets for cellulosic ethanol that were just completely disconnected from physical reality. The targets failed, the industry stalled, and the policy had to be repeatedly downgraded.
Wow. But it makes you wonder, why is the U.S. government so desperate to artificially reroute these supply chains in the first place? I mean, it isn't just about economic protectionism or, competing with foreign auto markets.
No, not at all.
Because there is a deeply troubling reality at the physical origin point of these minerals. Specifically when we look at cobalt coming out of the Democratic Republic of the Congo, or the DRC.
Yeah, and the global EV transition just cannot happen without the DRC. I mean, they sit on the vast majority of the world's known cobalt reserves.
Right.
But the extraction methods at the bottom of the supply chain present this massive ethical and geopolitical liability for the companies buying the raw materials.
Here's where it gets really interesting and honestly devastating, because the human rights data on this is it's grim.
It is.
Researchers from the University of Nottingham conducted these vast on-the-ground surveys of over 1,400 artisanal miners in the DRC, and we aren't talking about massive industrial machines here.
No, we are talking about individuals digging with hand tools in the dirt.
Exactly. And they found that nearly 37% of these miners are subjected to forced labor. Almost 1 in 10 are children. And the average daily income for this back-breaking, hazardous work, it's $3.28 a day.
Which is it is an economy of pure desperation.
Yeah. $3 a day? That's unimaginable.
And the surveys revealed that nearly 88% of the workforce is mining simply because they have no alternative means of survival. Almost 70% stated they desperately want to leave the mines, but they are just financially trapped.
But this creates a bizarre paradox for the global battery manufacturers, right? Because the UC Berkeley Law Analysis points out that the conditions in the DRC are such a massive PR nightmare.
Oh, a huge risk.
That companies are literally pouring billions into research and development trying to engineer cobalt out of future batteries entirely.
Right.
It's like a gold rush where the prospectors are so repulsed by the conditions of the mine that they're actively trying to invent a substitute for gold.
That is exactly what's happening. The DRC is effectively racing against the clock of global innovation, because if battery chemistry evolves past the need for cobalt, the country's primary geopolitical leverage just evaporates overnight.
Wow.
And when you look at the Berkeley law analysis of this, the tragic part is that the DRC doesn't actually need to invent groundbreaking new laws to fix the industry.
Wait, really? They already have the laws?
Yeah, the legislative frameworks against corruption, the labor protections, the transparency mandates, those all exist on paper.
Oh, so the gap is entirely in the enforcement. The local authorities either lack the resources, the infrastructure, or, frankly, the political will to actually enforce the mining codes in these remote artisanal sectors.
Exactly. And the energy transition is this wealth generation event, the likes of which we haven't seen in a century. But if the DRC cannot close the gap between the laws on paper and the reality in the dirt, the global market will simply innovate its way around them.
They risk missing out on the economic boom of their own natural resources.
Entirely.
So if U.S. domestic sourcing rules are mathematically impossible and manufacturers are actively trying to flee the human rights disaster in the DRC, how does the physical rock actually get out of Africa securely in the meantime? Because, I mean, somebody has to actually move the dirt.
Well, which brings us to the physical infrastructure.
Yeah.
Because you can't just mandate a clean supply chain from a desk in Washington, D.C. You know? You have to physically redraw the map of Africa to move these materials efficiently and transparently.
And the centerpiece of this effort is a massive project called the Lobito Corridor, according to the Atlantic Council report.
Yes.
It's an 800-mile rail network linking the incredibly mineral-rich copper belt, which spans the DRC and Zambia directly to a major port on the Atlantic Ocean in Angola.
And the U.S. Development Finance Corporation, alongside several African development banks, they are actually financing the modernization of this line.
Because historically, getting minerals out of this region involved, like, loading trucks and driving them over degraded roads, dealing with massive customs bottlenecks at borders. I read it could take weeks.
Weeks, easily. But this rail line has already cut transit times by 2/3.
That's huge.
The speed is important, sure. But if we connect this to the bigger picture, the structural model of the Lobito Corridor is what makes it a massive geopolitical shift.
Yes.
Well, for a century, foreign investment in African infrastructure largely followed an extractive single-use model. Like a foreign mining conglomerate would build a private road or rail line straight from their specific mine to the coast.
Let me guess, no one else could use it.
Exactly. It functioned like a straw, simply sucking resources out of the continent without integrating into the local economy at all. But the Lobito Corridor is fundamentally different. It operates on an open access model.
Meaning the track is basically a public utility.
Yes.
So a local Zambian agricultural business can pay a tariff to put their grain on the exact same train that is carrying cobalt.
Right, which dramatically lowers freight costs for the entire region. It catalyzes regional economic integration. It allows light manufacturing to spring up along the rail line because businesses finally have reliable logistics to move their goods.
But, okay, let me push back on this for a second. Are the U.S. and its allies really pouring billions into an open-access African railway out of a newfound commitment to regional integration? I mean, China has already spent years building massive infrastructure projects across the continent, like the Standard Gauge Railway in Kenya.
Oh, absolutely.
So isn't the U.S. just panicked that Beijing controls the supply chain and they're trying to build a rival belt and road right on top of China's footprint?
Well, the geopolitical strategy is certainly the primary driver. I mean, the Atlantic Council's infrastructure analysis makes it crystal clear that this is an arena of intense strategic competition. But the analysts point to a fascinating reality on the ground, which is strategic proximity does not mean strategic surrender.
Huh. What does that mean in practice?
Look at Djibouti, on the Horn of Africa. The United States and China both maintain massive active military bases there.
Okay.
Do you know how far apart they are?
How far?
Just 10 miles apart.
You're kidding? 10 miles.
10 miles. So the U.S. strategy moving forward isn't trying to force African nations to completely sever ties with Chinese investment. Trying to enforce a no-China footprint is just economically unrealistic for most developing nations.
Right. They need the investment.
Exactly. The strategy is to offer a highly competitive, transparent alternative. If a nation is wary of the debt conditions attached to a Chinese infrastructure loan, the U.S. and European coalition wants to ensure there is a viable, high-quality alternative on the table.
And the Lobito Corridor isn't the only one. They are trying to build out an entire network. I saw plans including the Liberty Corridor linking Guinea and Liberia, the Northern Corridor through East Africa, and the Nakala Corridor moving through Mozambique and Malawi.
Yeah. And perhaps the most crucial piece of this puzzle isn't a rail line at all, but a processing hub.
Morocco.
Yes. Morocco is actively positioning itself to be the middleman for the entire continent. They have massive wind and solar energy potential, and they're using it to build green gigafactories. But crucially, Morocco has an existing free trade agreement with the United States.
Oh, which ties directly back to that 80% IRA target we started with.
Exactly the connection. You can extract raw materials from across the African continent, move them down the open access corridors, aggregate them in Morocco to be chemically processed using clean, renewable energy.
And ship them to the U.S. completely legally compliant with the free trade requirement.
Bingo.
Okay, so we have the U.S. demanding cleaner supply chains, we have the human rights crisis forcing the issue, and we have these massive new rail corridors moving the rock.
Right.
But how does a regulator in Europe or the U.S. actually verify any of this? When a battery rolls off the assembly line, how does anyone prove that the lithium inside came down the open-access Lobito Corridor and not from a forced labor camp using washed customs documents?
That is the multi-billion-dollar hurdle the entire industry is currently slamming into.
Because you can't just physically look at a piece of refined cobalt and know its ethical history.
Exactly. The only way to solve this is through massive, unprecedented data tracking.
And Europe is really leading the charge on this with the EU battery passport, right? We read the Cognizant breakdown on this.
Yes, and the timeline is aggressive. By February 2027, every single electric vehicle, light transport, and industrial battery over 2 kilowatt-hours sold in the European Union must have a digital passport.
Accessible via a QR code printed right on the casing.
Right. And it functions as a complete digital twin of the physical battery. The data architecture is just staggering. It's designed to track the total carbon footprint of the manufacturing process, the exact percentage of recycled materials inside, and comprehensive social due diligence.
Meaning auditable proof that human rights were respected at the exact mine where the materials originated.
Exactly.
So what does this all mean for you, the listener? When I first looked at this, I thought, okay, it's essentially a Carfax report for your battery. You scan it, you see the history, you know what you were buying.
Well, a Carfax report just tells you if a car was in a fender bender 3 years ago. The battery passport is attempting to track the ethical and chemical origin of every microscopic grain of material from the moment it leaves the dirt in Zambia until it sits in a driveway in Munich.
Which sounds impossible.
It is incredibly difficult.
Yeah.
The sheer volume of data required is causing a massive headache for the industry, specifically because of data fragmentation.
Well, yeah, because you have massive, technologically advanced European automakers trying to sync their databases with tiny independent mining outfits on another continent.
Right.
If a Tier 3 supplier, basically a small-scale operation deep in the supply chain of a developing nation, is already struggling with basic operations, how on earth are they going to integrate with complex, high-tech digital tracking systems by 2027? I mean, they don't have teams of software engineers.
This raises an important question, and the reality is they don't. Which is why technology analysts are warning that the entire system will fail if those deep-tier suppliers aren't actively supported.
So what's the solution?
The proposed solution from Cognizant is something called the PASS framework. Prepare, assess, scale, and sustain or standardize.
Okay.
The core idea is that the massive companies at the top of the supply chain have to provide supplier enablement programs. You cannot expect a small mine to build a custom API interface.
Oh, it's absurd.
So you have to hand them standardized, low-code digital templates. That way they can essentially just plug their basic operational data into the larger global system. It transforms compliance from just PR rhetoric into auditable ROI.
But wait, the passport doesn't just display everything to everyone, right? There's a massive intellectual property risk if a company broadcasts the exact chemical recipe of their cutting-edge battery to the entire internet.
Oh, for sure. Which is why the digital architecture uses role-based access.
How does that work?
So if you, the consumer, scan the QR code with your smartphone, you might see a high-level summary of the carbon footprint and the ethical sourcing guarantees.
Like a nutritional label and a moral background check.
Exactly.
Yeah.
But if a government customs regulator scans that exact same code, their credentials unlock the deeper compliance data and the supply chain audits.
Oh, very smart.
And then there is the end-of-life layer, which might actually be the most important part.
What happens at end of life?
Well, when that battery degrades in, say, 15 years and gets sent to a recycling facility, the recycler scans the passport, and their specific credentials unlock the exact chemical blueprint of the battery.
No way. So they instantly know how to dismantle it safely.
Yes, they know how to recover the cobalt, the nickel, and the lithium with maximum efficiency. It creates a closed-loop system.
That is brilliant.
That level of data transparency is what actually fuels a circular economy. If you can recover and reuse the materials efficiently at the end of the battery's life, you drastically reduce the need to dig new holes in the DRC or build new rail lines across Angola.
It's the exact recycling loop that the U.S. policy is currently failing to incentivize. It is genuinely staggering how interconnected every single piece of this puzzle is. I mean, if we step back and look at the entire board, the trajectory of this industry is just wild. We started with the U.S. government writing ambitious market value targets for critical minerals that the math says are practically impossible to achieve without relying on gamesmanship.
Yep. And that legislative pressure, combined with the grim reality of forced labor and poverty for artisanal miners in the DRC, is forcing global manufacturers to try and innovate away from problematic minerals entirely.
Right. And to safely extract what we do still desperately need, the physical logistics of the African continent are being rebuilt with open access rail corridors, shifting the geopolitical balance of power and offering real alternatives to Chinese infrastructure.
And to hold all of these disparate pieces together, regulators are demanding a new level of digital transparency, forcing the creation of battery passports that track the carbon and ethical footprint of the dirt straight to the consumer's driveway.
It really forces you to completely reevaluate the physical world around you.
It does.
The next time you are walking down the street and an EV silently glides past, don't just see the aerodynamic metal and the clean software. I want you to picture the 800 miles of Angolan railway, the complex digital QR codes tracking microscopic data, and the massive, high-stakes geopolitical chess match riding inside its chassis.
It's a phenomenal achievement of human coordination. But, if we are truly looking at the whole board, there is a massive unresolved tension here.
What's that?
Well, we discussed how battery manufacturers are racing to engineer critical minerals like cobalt out of their designs entirely to avoid these massive supply chain headaches and ethical liabilities, right?
Yeah, the substitute for gold analogy.
Right. But if those engineers succeed and the global market completely bypasses the DRC, what happens to the 87% of those artisanal miners whose pure survival depends on that grueling $3.28 a day?
Oh.
In our rush to build a clean, ethical, high-tech future, are we about to pull the economic rug out from under the very people we are trying not to exploit?
Wow. That is a heavy, incredibly complex question to wrestle with, and it really proves that the green transition is anything but simple. Keep questioning the systems you interact with every day, keep looking past the surface of the technology, and we'll catch you on the next deep dive.